For anyone who is not familiar with Machining Cloud, it's an independent provider of product data for various manufacturing and tooling related products. It's very easy to use and does not cost you anything. If you have not yet used Machining Cloud, here's a brief introduction of how to access the application and build a couple of basic tools to get you started. The Machining Cloud app is accessed via the internet from the Machining Cloud website. When you first go to the main Machining Cloud webpage, it will look like this. Just click the Get Started link on the page. If you have an existing login, use that link. If you are new to Machining Cloud, just sign up. The sign up is very easy and only requires a few items of information marked with red asterisks, as you see here. You will use a password to get into the software. It does not require any license or credit card information. Again, this is free for you to use. Once you register, it will take you to the Machining Cloud app. In my case, since I already have an account, I will simply log in. This is the main interface to Machining Cloud. If we do a brief tour of the interface, let's first start in the upper left corner where it shows the Kennametal logo. Here you will see a listing of 40+ vendors that Machining Cloud now supports. On the right you will see another listing of vendors that Machining Cloud is working on that will be available soon. In Machining Cloud's latest version, there are over 825,000 different products ranging from drills, taps, mill tools, turning inserts, etc., and over 600,000 3D models currently available for download. Let's get into what it takes to make a tool. If we jump back to the far left, you will see 5 buttons. These functions are the same as what's listed in the middle panel on the screen. Let's start with Job, then click on Job Management. Think of a job like a tool list for a particular project that you're working on. Let's start by creating a job for what we're about to do, and we'll give it a unique name. Just below the job name, we'll find the workpiece material where we can predefine the material we will be cutting for this particular job. In this case, let's select a high-temp alloy. Once we click that, you'll notice that high-temp alloys has a further subclassification. In this case, let's select S4. The workpiece material will act as a filter when searching for and selecting tool components. We'll discuss this more in a moment. Now let's start to build a tool by clicking Search, then Search by Product Family. We will start with the milling tool. You will notice on the right side you have various filters. At the top you will see that workpiece material S4 that we defined a moment ago. In this field, there's a quick search if you already know a part number of the component you're looking for. If you don't know the part number, you can start by selecting the type of application you're wanting to do. In this case, let's select a shoulder milling application. Once we add the type of application, you will notice another filter was added to the top. Let's add one more filter and select a specific cutting diameter. In this case, let's select 0.25. Now let's take a quick look at the 2 classifications in the center panel. Notice the quantities in the upper right corner of each have reduced considerably. At this point, let's select an indexable mill. Notice at the bottom there are 3 listings that fit the filter criteria. Let's select the first one and add that to the tool assembly in the job we just created. At this point, you will see the tool component you just selected in the center panel. Notice the blue plus symbols above and below. This is part of the power of Machining Cloud. It's smart enough to know the items that need to be or can be added to what you have selected so far. Also on the right side, let's open the 3D viewer. This shows us the preview of the selection so far. At this point, it's just the holder and a generic insert. Now let's add a specific insert to the assembly. Now before we go any further, notice the icon next to the insert. This displays the recommended feeds and speeds from the component manufacturer. This gives a multitude of information from the manufacturer about how the cutter should be used. There are slide bars to adjust bits of information on how you intend to use this. CG Tech's suggestion is to leave the slide bars as they are if you intend to use Vericut's force optimization later on in your process. Now if we work our way up the list, you see an option to add a collet. In this case, we're going to do a shrink fit type of holder, so we will skip the collet altogether. Again, because of the power of Machining Cloud, it only lists the items that fit with your previous selected components. In this case, I want a hydraulic chuck from the high performance line. At this point, you can see we have a complete tool assembly built up. If you look at the 3D viewer window, you will see by default the 3D rendered model, or the detailed model as we like to call it, is displayed. Now if I click the other icon, I get a spun representation of the tool, or a 3D anti-collision model. This is the simplified model that is most likely preferred to be used within Vericut, since I do not need all the details of the assembly. Now let's add this tool to the current job we created. You will see we are displaying the tool list so far consisting of just one tool. Now let's build a turning tool by selecting the Search by Product family again, then select Turning and then Profiling. I will select the top-notch profile. As a side note, each of these selections we are making acts just like a filter to select the desired category. Let's start with the tool holder. In this case, we will look at the inch tools. Let's select this option for the type of tool holder we want. In this case, we have 10 options to select from. Let's scroll down and select the last one to add to this tool assembly. Here again, you can see the preview of the 3D components. Let's add a specific insert. I will select the last insert listed here, and then we will add that to the tool assembly. Let's add one more adapter to this assembly, so again we select the blue plus. Let's select this KM4X holder, and finally we will add that holder to the turning tool assembly. You will see there are additional adapter selections that can be made, but for now this is sufficient. And on the right, once again, you will see a preview of our 3D assembly. As we add this last tool to the current job, you will see that we have 2 tools now listed within this tool list. As we export this job from the Job Information tab, we will use the CG Tech Vericut option. When finished, it will display the Machining Cloud zip file that is generated in your Downloads folder. This is a single zip file that can contain one or multiple tool assemblies and all the necessary data that goes along with it. This zip file does not need to be unzipped, as it will be read directly into Vericut's Tool Manager using the Machining Cloud interface. After the tools are read in using the Machining Cloud interface, you will see that we have 3D geometry along with driven points for each tool. Also notice that each cutter has its own stock material records that were created when the tools were read in. This information in the middle panel can be used in additional checks within Vericut simulation and for force optimization.